Good afternoon, everybody. Welcome to class today. Thank you for joining me. Thank you for joining me, whether you're watching live or you're watching the recording. I appreciate you watching. So today we're moving on to the concept of recursion. I'm going to cover recursion in depth today, right? The big whole point of what I'm working with today is all about recursion and working with recursion in Java. So we've talked about recursion in other courses, and if you have been in those other courses where I've dealt with the concept of recursion here is basically the same. Right? What we're talking about when we're talking about recursion is one of the ways that we have to take an operation and do it multiple times, do it over and over again. Right? Starting in the next module, I believe, if I'm not mistaken, we'll start looking at iteration, and we'll discuss how iteration is different from recursion. But for the point where we're getting started here, I do like to start out talking about recursion. Because really for the Java class, right, like we can talk about recursion from one of the perspectives of like memoization. Right, memoization in programming is basically noticing that there is a pattern in terms of what's being returned from something that's looping over and over and over again. So if you're, for example, traveling down a binary tree, you notice that there is a pattern in the binary tree and you memoize that pattern into your function in the recursive call or via some other method, so that you are not doing a bunch of extra work. It gives us different abilities to do different things. And so we're going to look at the concept of recursion today and do a lot of examples in recursion, and if time permits, I do have a little code challenge for us to approach today. So the first thing I want to do, as per usual, is that I just like to define recursion. One of the things that we like to do as we're talking about any new topic is we like to define that topic. Right? So I want to take a word and I want to, just let you know what it means in this context. Right? And so when we're talking about recursion, there are a lot of things that could be defined as recursive. And I think that is a big thing for us to consider, right? Is this idea that, every day we look at problems kind of in our lives or through some pathway, and we kind of describe that problem in relation to itself, right? We basically say, I have this problem, and then, I'm going to utilize something related to that problem to help me solve the problem, right? Like an example I give oftentimes is when you think about like a dictionary, and like, you might look up the term recursively. And the definition for the term recursively is the process of being recursive. Right, so you're using the term that you're trying to define within the definition, and so you're just kind of self-referentiating, if that's a word. That's might be a bit of a stretch for a Monday afternoon. The term in the definition. Like the example that I give here is the second bullet. It's not giving you the example of a compound sentence, but it's giving you the example of the definition of a compound sentence, right? So a compound sentence is two sentences. So within that definition of what we refer to as a compound sentence, we're using the term sentence. Right? So to understand what a compound sentence is, we must also understand what a sentence is, because that is referentiating back to the definition that we're working with. And we can also kind of think of it as like two mirrors reflecting itself, right? If we are utilizing a recursive method, it's basically looking at a copy of itself and just bouncing something off of it for it to just be returned back to it and run all over again. All right, so if we want to get more specific and talk about recursion in programming, the basic way that we can think about it is that recursion is when a function invokes itself. And so the way that we can kind of think about it in that sort of way is that the method is cloning itself, right? Like it's created sort of this instance of the method where the method needs itself to be able to do the job. Right? So you can think about like, oh, I'm gonna make a clone of myself to help me do my yard work. Right? Like if I'm a recursive function, I'm gonna kind of make a clone of myself to help me do the job I need to do here. And so using recursive methods requires us to be creative about how we think about solving a problem. Right? And when we get into the idea of iteration, a lot of what we do with recursion, we can also do an iteration. It's not always a one-to-one sort of scenario, right? There are some things that are more efficient to do one way or another, and there are things that, have varying levels of complexity one way or another. So when we think about the idea of recursion, and as we talk about in the future, iteration, we've kind of been approaching code and problem solving with code from a creative standpoint up until this point, right? But the thought process and kind of wrapping our brains around what we need to do, right? How we need to call specific parameters, where we need to put function calls, and all this kind of stuff within our program, the kind of things that we need to do to be able to solve the problem using this recursive method. And so with that being said, right, there are 3 laws of recursion. And the first one is that there is a base case. And so last week we started talking about the ideas of conditionals. And that's why I talk about conditionals and recursion together. Right? Because the conditional gives us that base case. So in order to have a successfully recursive method, one of the 3 laws of recursion dictates that we need a conditional to provide for us a base case. And what this base case does is it provides a path for us to get out of our loop. Right? It provides us a path through the code that doesn't call the method or the function again. Right? So we have to have some condition that at some point becomes false so that the method stops recursively running. So that's our first law of recursion. Our second law of recursion is that there must be a recursive case, which in this case means just a line of code that calls the function within itself. Right? One of the things that we talked about when we started talking about methods a few weeks ago, remember the terms method and function are used basically interchangeably. In Java, they are methods, but in other programming languages, they might call them functions. So we have this method call or this function call that is within itself. right? And so a couple weeks ago, we talked about the idea of, we can basically call a method or invoke a method from anywhere, right? And that includes within itself. So when we start to deal with that, right, wherever the point where we invoke that method is, it's just going to jump to the top of that method and work with the code that's, before that line of invocation. And this does change the way that our stack runs, right? Like a couple like in the last module, we looked at the idea of a stack diagram, right? And how, as we're kind of reading through a program, we can kind of, layer the different function calls on top of one another. And when we layer the different function calls on top of one another, we can visualize a flow of data through our program and the flow of a state of a particular variable through our program from beginning to the output. But in recursion, as we're making these recursive calls, we have a function that's calling itself, and it's getting stuck in this sort of loop for at least a little while. And then it has a value that it passes on. So it does sort of complicate our stack diagram just a little bit, right? Because it's adding this extra little curly Q in it. Now, within this recursive case and within the code that surrounds this recursive case, we need some other code that addresses that base case. Right? And so we need some other code that addresses that base case where it can move it from a true state to a false state. And this could be any number of things. Right? And that's what we're going to kind of work on doing as we are approaching our demonstrations today. We're going to try to do some different examples of this here, where we're talking about taking this and breaking that base case, taking that condition that we started out as true and turning it into false. Because if we don't have this thing that breaks our recursive call, then what we end up with is an infinite loop that eventually will overflow our buffer of memory. When we overflow our buffer of memory, it causes data to be overwritten into other areas, which could cause code to be written into those other areas that we don't intend to be there, which is why buffer overflow could be oftentimes used for. Yes, at the end of the day, like a loop which is iteration and recursion are similar concepts. Right, a for loop or a while loop, those are iterative processes, whereas recursion is a recursive process. But yes. So with that said, let's jump into a code window here. And let's see some examples. So I know, since I'm going to be working with a method that is going to call itself, I then know that I basically need a method to be working with here. So we know that everything basically that's in our output is going to be called via our main method. So we can just kind of empty it out, leave it alone for the time being. And let's create just a void method here, and we're going to call it just basic recursion. So let's create a public static void basic recursion. We will need an argument or / parameter, right? That's another term for what we use here. So we will need some sort of parameter when we call this function, because it's going to be the ability to manipulate that parameter or that argument that is going to move us from that base case to that break case, right, where we move from true to false. And so all I really want to do here is I just want to count, right? So I'm going to take some value, which in this case, let's say the value is 1. So we'll make the value 1. Or really, we can make the value whatever we want it to be, right? Because we are doing it with our parameters. So we won't define that value until we invoke or call our method here. But if we're going to count and we're going to count up, let's say we're going to need an integer value, and we're going to need the integer value to be, we'll call it base for the purpose of this example. And so let's say I want to count from base. So I want to count from base, whatever base is, to, let's say, 100. So I'm going to start at base, I'm going to increment base, and I'm going to move base to 100. So I need a condition here. I need an if statement that is going to check to see if base has reached 100 yet. Every single time we're going to tell it a different value of base. And so we need this conditional statement to see if base has gotten to 100. So we can say if base is less than or equal to 100, then we can print the value of base. That's system dot out dot print line base. And so now what we want to do is we want to make our recursive call or our recursive case that is going to in turn increment the value of base, right? So we're going to keep on using the same parameter value that we use in everything here. And we're going to call our basic recursion function. And this will recall our function with the value of base, which is just whatever the current value of base is, plus 1. So it'll take the current value of base, whatever we call that to be, add 1 to it, and now base plus 1 is the new parameter value of base. So it's going to check that against that. So it would start 1, 2, 3, 4, right? If we start at 1, 1, 2, 3, 4, 5, 6, and so on. Right, so then we make our call in main for basic recursion, and we started out with a value, let's say 1. And so this is a recursive way that we can count to 100 in Java. So if we were to run this, we'd just see it count to 100. Right, got us all the way to 100. Now the important thing to remember, right, which is why we have this base case here, if we remove that conditional, then we're stuck in a loop. And so now it's going to just count into infinity until the buffer memory overflows and it crashes the program. Right? In an earlier thing that you all worked on as you were testing code, you got to see firsthand something basically, and there it goes, it crashed. You got to see firsthand basically something loop until it crashes like this. Right? And it's pretty cool that it can count like that, right? Like in just those few seconds there that we let it run, it got to 25,377. But it kept going. Right? And it's at the point where it just keeps going and it doesn't realize kind of how far it needs to go or something like that, where it can't handle the memory properly. That we get this buffer overflow, we get the memory overflowed, we get the stream encoder crashing, and we just get a whole mess of errors in our output here. Now, one of the good things about this is that, I can kind of use this as a method to kind of do whatever we want with the values, right? Like I can pick a starting point, I can pick an ending point, I can do a lot of different things here. Right? For example, I can add another parameter for end, integer end. And we can compare our starting value or our base value to our ending value. Now, our ending value is not going to change, but as we can see here with this squiggle line, once I have two parameters in my function, I need to so recursion itself is always done with a conditional statement. I can put a loop in here also, but you're not recursing with a loop, you're iterating with the loop. Like I can put a while loop or a for loop inside of this if statement and let it go. Right, and it'll do its thing every time it runs through just like it was regular code. But to be recursive, I need to have a breakpoint being my conditional statement, and this call is what does the heavy lifting of the loop in this case, right? Or the recursion. The fact that it's, hitting this function call / method call and jumping back to this method. All right, so as I was saying, when I have two parameter values, like I've included here, one for the start and one for the stop, I need to include both of those when I make my recursive call. Now, the ending value is not going to change, right? Like if I made my ending value change, then it's going to go off into infinity also. Right? Because, for example, if I did something like end plus 1 here, right, that's going to move both my starting condition and my end point by 1. Right? So think about, say you're running a race, and then there's for every step you take, somebody's taking the finish line and moving it one step ahead. That's what would be happening there. Right? So we want this end value to remain constant. So if our end value remains constant, then even after we recall it, it keeps the same value. So it's checking against the same number. So let's say instead of, counting up to 100, we call this function in our main with 1 and 10. Right? So in this case, it goes by the order in which these numbers are put into our parameters here. So 1 becomes the base value, 10 becomes the end value. And so if it's 10 here at the start, the end value that is, if it's 10 here at the start, I'm not changing it at all here, so it remains 10. Whereas our base value gets incremented by 1 as we recurse our function. And so it becomes 1, and then 2, and then 3, so on and so forth. So, this is essentially a program to recursively count us to 10. Right, so now we have the ability to manipulate our starting point and the ability to manipulate our ending point. Now, one of the things that we might want to do here is we might want to put that power in the hands of our users. Now, I'm going to do multiple conditions here where I might use scanner. So I'm going to import scanner at the top of my program. Import java.util.scanner. But I'm going to create my scanner object in a bit of a different place. I want to come right here below my line 3 and add my scanner object here. And what we're doing here is we're instantiating our scanner object at the class level instead of the method level. So over the past several weeks, ever since we learned about scanner, the way that we did it was we just put it inside the method that we wanted to use it in. And in that case, we instantiated it at the method level, which scoped it to the method level, meaning that we couldn't actually use that same object to operate as scanner in other methods. But if we put it here in the class level, that will allow every function in my class to be able to utilize the same scanner object to be able to get input from our user, which is, pretty great. So if we start to add a scanner object here and we say scanner new equal, or scanner in equals new scanner on system.in, we could try to use that, but we'll have a little bit of a problem. Right? If we just say, let's say system.out.print, enter starting number, and then we'll say int start equals in dot next int. We see there that it's got the little our little red squiggle there. Got our little red squiggle there under n. If we hover over that, we see that it cannot make a static reference to the non-static field. So we could actually make this a static scanner object. So then here, in place of 1, we can use start. So let's run this and see what happens. We run it, we're going to enter a starting number. I'm going to enter 2, and it counts from 2 to 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. If I wanted to deal with the security of my scanner object here, I could add a public or a private to it. So this could either be a public scanner or a private scanner. And that just deals with the locations in memory that can access this scanner. So if I have a private scanner object, the only methods that can access this scanner object are the ones that are in the same class with it, in this main class, in this file. If it's public, it can be accessed by different methods from other files, which if it's something that's sensitive, right, like if it's a field that could potentially be taken advantage of for a certain situation, right, if it were public, then other files can manipulate that and work with that. So it's not necessarily something that we would want to do here. But just to see, like, I can run it and the exact same thing happens on my output for our purposes here. Since we have our starting number, we'd also want to enter our ending number. So int end will equal end.next int. Getting ahead of ourselves here, let's go back and let's put a little message here to our user. So system.out.print, enter ending number. And so now instead of start and 10, we can go start and end. And we have a simple recursively called program that can take 2 points from our user and count between them, right? So if we wanted to count from, say, 12 to 127, we could see that happen, right? It starts at 12, and as we go down, we get to 127. Right, and it did that for us without having to write out a bunch of extra code. And we did it recursively here because we used this call to the same function that it is inside of, which makes things happen, right? Our end value remains constant. Our base value we increment by 1. We can take this incrementation and change it to be whatever we want it to be. Right, however we want it to increment. So let's say we did 3 here. We could run that. And we could just say, oh, start at 3, end at 333, and give me my numbers. And so we get 3, 6, 9, 12, all the way up to 333. And so that's one sort of standard proof of concept for a recursive method. Right? There are other things that we can do in terms of taking this if condition and breaking it. That will help us out here, right? So for example, let's kind of do something else here. Let's work with a Boolean flag, right? Which is something that I believe your text talks about. We have Boolean flag variables, which is basically just a variable that I can use to call a true or false value. Right? And the idea is that I can take my flag and I can flip my flag between true and false, and I can use it to address conditionals or loops or whatever I want to use it to address. Right? So in this sort of instance, we would need some sort of function, or rather we would need some sort of Boolean variable pre-called for us. All right, and there are some other ways that we could kind of play with this and do this. But, to me, having it pre-called makes it work a little bit better. So what I'd like to do is I'd like to write, just to kind of prove my point of having the scanner at the class level, I'd like to write another function here to take my input for this particular example. So what I'm about to do in this method, you could also do in main, just the same, and it would work just the same. So we'll call this public static void get input, and we will need a Boolean value to be brought, or no, this is the input one, not the one that I'm going to make recursive. I'm getting ahead of myself. But basically, I want to have a flag variable. I want to have some sort of Boolean variable. We'll call this one start, and we will set it to true. So starting with something being true, which is also something that we'll address when we start talking about iteration over the next couple of weeks. Starting something as true, we call it seeding. In this case, we're seeding the recursion, or we could be seeding the loop. Just making sure that it gets started by having the very first value that it assesses to always be true. Right, so in this case, we're having our starting value start with true. I want to get some sort of word that'll be some sort of password. So in this case, we will system.out.print line, or in this case, print, enter password. And now this is one of the cases where we could get a little bit like confusing with it and flip our logic around. Because what I'd like to do here is do like a little password check sort of situation. So I think instead of true here, I'm going to make this start value false. And we will, instead of calling it start, we'll say correct. And we'll call this correct. So whenever we start it incorrect. And we won't know if it's correct or not until they enter the password. And just because something's false, it doesn't mean that my if conditional won't resolve to true, right? Which is one of those complicated things here that we end up messing with. But then we can call our function. We'll call it check password, or we actually need to get the password, right? So we'll say string pass attempt equals new string in dot next line, and then we will call our check password function, which we haven't written yet, with our value of correct and our value of pass attempt. So now we know what we're going to do here is we're going to call a function called check password that we haven't written yet. Our check password function is going to be passed a value here that is going to be checking to see if the password is true or false. It's going to start off as false by default. And then the password attempt, which is going to be whatever our user enters in. So now let's work through our check password function. So that would be public static void check password. And we know we need two arguments here, or two parameters. So we know we need a Boolean of, let's call it success, and a string of attempt. So in this case, I'm going to need to take advantage of my if and else statements. To work with my logic here. And so I can write an if, and we can use our not operator. So if exclamation point success. If not success. And so that's the value that we're going to be checking for our recursion. All right, so if not success, then what we want to do is we want to system and actually I want to do something else before I do that. I'm getting ahead of myself here. I want to check to see if the term is correct first. So I want to say if attempt dot equals some string. We'll call it treehouse1. That'll be our password. And so now in this case, what we can do is if it's correct, we can change, and I want to actually get this out of here. I don't want that in there. I want this to be its own separate conditional statement. If the password that we get entered in here is correct, then I can go ahead and take my Boolean flag. In this case, it would be success. And set that equal to true. So by default, it comes in as false. But if the password equals the correct password, we're going to change it to be true. And we can also print out something like success. So we can say system.out.println success, you're in. Now, if this did not succeed, right, if this was not true, right, we seeded our correct with false. So if this is not true, it'll skip this. So success will still be false, which means not success. Or if success is not true. So if success is false, then this if conditional will evaluate as true. We can system.out.print line incorrect. Try again. We can set attempt equal to n.next line. And we can call our recursive function with check password, success, attempt. So in this case, this is all about where we change our variable values. Right? So if you get the password correct, right, it's going to bring in this value of false. One of the things to notice is where I set this value of false to, by the way. Right? I set it in this other function that is not being recursed. Because remember that every time that I run the function, it's going to execute the code that's in the function, right? So if I put a Boolean success in here and set it equal to true or false, right? Every time it runs the function, it's going to run this line of code, which is going to reassign the value to be false. So it would essentially break anything that we're doing, right? Just by resetting it. So if it's treehouse, we're going to say it's true. In this case, all we're doing is we're taking that Boolean flag and we're flipping it. We're flipping it from false to true, so that when it gets to this point to check to see if not success, well, then it would be if success, because it would be true. Right? So we're checking for if not success, in which case that would be false. It's going to say try again. It's going to collect another attempt from the user, and it's going to recurse to check the password again. So if we were to then go in and call that in main, which is what we need to do here. Let's comment out these lines. I want to call this get input function, and then it'll chain the call from my main. So I'll call get input, and then get input calls check password. Get input, and we can give that a little run. So it's telling me to enter a password, and I can enter in something like password 2. And it tells me it's incorrect and I should try again. So I should try another pass. Incorrect, try again. But if I enter tree house 1, we can see success, you're in, and I get the little greater than symbol. My stop has turned to run again, which means that it has stopped. Right? So we've moved from... So we use this base case to flip a flag, and we used that to determine whether or not we are going to recursively call our function or method, right? So these are two completely different ways that we can use recursive calls. One using values and the other using Booleans. And they're both recursive calls that are valid recursive calls because they both follow the 3 laws of recursion. We have, in both of these examples here, we have a base case, we have a recursive case, and we have a means to break the base case. Which results in us getting what we want to get. So we've got about 10 minutes left in our hour here. Let me check something really quick. And we can see what we're going to do with this last 10 minutes from there. And so just to kind of give you a little, like this, you can utilize this proof of concept here as one of the ways that you can do the lab. But just like with every other lab, there are probably, a dozen different ways to do it. There are a few different ways that you can write recursive methods that would allow you to recursively loop your guess a number program. Another big thing to note for that is that this also works with random. Just like it worked with scanner here. So if I want one random number that I can call once and use in multiple different functions, I do want to call it at class level. Because otherwise, if I try to do it within the function that is recursing, I'm going to end up with different numbers every time my method runs, because it'll reassign the values. But there are other ways to get around that again, right? Like if I call that here and just pass it straight through like we were doing here is another way to do it. Right? Like I could create my random number in main and then just treat it like the end value here where I'm just passing it straight through and not changing it. Right, so there are different ways to approach these recursive methods and different ways to call things and different ways to implement things. And at the end of the day, it's just going to be what makes the most sense to you. So with that being said, I don't think we have quite enough time left to do the code challenge that I would have done here. So I think we'll go ahead and let this be it. I'll send this out along with the recording here in just a few moments once we're finished here. So while we're wrapping up, we'll take any questions that anybody has. In an attempt to make sure we're all good here. One more time, can you explain when to use print and when to use print line? Yes. So I'll just do it here in main really quickly. Print line prints a new line. So at the end of a statement that is print line, it will always line break. So if I had multiple print line statements, it's going to print them all on separate lines. Line 1, line 2, line 3. If I use just print statements, a standard print statement does not line break. So as many print statements as I have in a row, it will just print these things all on a singular line. Line 1, line 2, line 3, all on one line. Right, so the reason that I will use a standard print statement in a situation like this over a print line is because it will put the cursor right beside where I write enter password. So it makes more sense from like a user interface standpoint. Right, if I put print line here, it'll still work, but it'll jump my cursor to the next line where I'd be entering the data. And so that's how that works. Cool, cool, cool. Any other questions as we are kind of wrapping up today? Again, if you're watching the recording out there and you think of a question, please send me an email or a Teams message and we can figure it out and work through it. We'll just hold for another minute or two here. Just to see if there are any more questions for the day. All right. Looks like everybody here is good. Once again, if you're watching the recording or if you think of a question later, you can send me an email or a Teams message and I will answer that question for you. That's all that I have for you for today. Thank you for watching. We'll see you next time.